There is a ticking time bomb located 650 light-years from us. When it goes off, it will eject a wave of fiery radiation and molten debris, tearing across the Milky Way, destroying everything unlucky enough to be in its path. Any planet caught too close will be torn apart, its rock melted into magma, its atmosphere ripped clean off. And this ticking time bomb is too close to us. Close enough that if we raise our eyes at night, we can spot it without help from any telescope. It is one of the brightest objects in the night sky. It is called Betelgeuse, a blazing red supergiant, and soon enough it will go supernova. But how soon is soon? Centuries away? Years? Days? And what would that mean for life here on Earth? Searching for answers, scientists have turned every instrument they have toward this dying giant, poring over its every flicker and shudder for clues to when the end will finally come. And the closer we look, the more this star keeps catching us off guard. Welcome to Cosmic Chronicles. We have noticed that 85% of you watching right now aren't subscribed. If you've ever enjoyed my video, do me a favor and hit the subscribe button. It helps this channel grow, and the bigger the channel gets, the more valuable content you enjoy. Now let's start from the basics. To understand just how strange Betelgeuse's behavior is, you first need to grasp its almost incomprehensible scale. Betelgeuse is a red supergiant. It's a star in the final stages of its life, and it is swelled to a truly colossal size. If you were to place Betelgeuse where our Sun is, its fiery surface would swallow Mercury, Venus, Earth, and Mars, reaching out toward the asteroid belt. It's so vast that hundreds of millions of our suns could fit inside. This giant is located in our cosmic backyard, though measuring its precise distance is tricky. Estimates have varied, but recent analyses place it somewhere around 530 to 650 light-years away. This proximity makes it one of the brightest stars in our night sky, though its brightness is famously inconsistent, a key part of its enigma. A star of this immense mass, estimated to be around 16 to 19 times that of our Sun, lives fast and dies young. While our Sun is a stable, middle-aged star at 4.6 billion years old, Betelgeuse is a cosmic youngster, estimated to be only about 8 to 10 million years old. Yet, it has already burned through the primary fuel in its core and is hurtling towards its end. That end will come in the form of a Type II supernova, a cataclysmic explosion that could, for a few weeks or months, shine as brightly as a crescent or half moon and be visible during the daytime. It's an event humanity hasn't clearly witnessed in our own galaxy for over 400 years. The general consensus among astronomers is that this will happen sometime in the next 100,000 years or so, a blink of an eye in cosmic terms, but an eternity for us. So, when Betelgeuse started acting up, it wasn't just a scientific curiosity. It felt like a front-row seat to the processes that precede one of the universe's most violent events. And in late 2019, the show began. Between October 2019 and February 2020, something unprecedented happened. Betelgeuse began to fade. Week by week, it grew noticeably dimmer, a change so dramatic you could see it without a telescope. This red giant, normally one of the 10 brightest stars, plummeted in rank, at its dimmest falling out of the top 20. The star lost about 2/3 of its normal brilliance. Immediately, speculation ran rampant. Was this it? The final sputtering breath before the supernova? The internet lit up, and astronomers scrambled to point every telescope they could at the dimming giant. A supernova at this distance would be completely safe for Earth. The so-called kill zone is estimated to be within about 160 light-years, and Betelgeuse is well outside that range. But we would get a spectacular light show. But as quickly as it faded, it began to recover. By April 2020, Betelgeuse was returning to its usual fiery self. The supernova party was over. But the real scientific investigation was just beginning. What had actually happened? Thanks to incredible observations from instruments like the European Southern Observatory's Very Large Telescope and the Hubble Space Telescope, a culprit was identified. It wasn't an internal change signaling imminent doom. Instead, it seems Betelgeuse had sneezed. Red supergiants have turbulent, boiling surfaces, and it appears an unusually large plume of hot gas erupted from the star. This colossal mass of plasma, estimated to carry a mass several times that of our moon, traveled millions of miles out into space. As it moved away from the star, it cooled, allowing elements to condense into a vast, opaque cloud of dust. It was this enormous dust cloud, positioned between Betelgeuse and Earth, that blocked the star's light. More recent analyses show it was likely a 1-2 punch. This ejected dust cloud combined with a temporary cool patch on the star's surface to create the dramatic effect. So, mystery solved? Not quite. Because the Great Dimming was only one of Betelgeuse's strange habits, and a bigger question remained. Why is Betelgeuse so prone to these violent outbursts? This event didn't explain the star's other, even deeper puzzles. Beyond its dramatic outbursts, Betelgeuse harbors two fundamental mysteries that have stumped scientists. The first is its rhythm. Like many variable stars, Betelgeuse pulsates, expanding and contracting in a fairly regular cycle that lasts about 400 days. That's well understood. But layered on top of that, astronomers have noted a second, much longer and more subtle cycle of dimming and brightening, one that repeats roughly every 5.7 to 6 years, or about 2,100 days. This long period didn't fit neatly into standard models for a single star of Betelgeuse's type. It was an anomaly, a clockwork rhythm with no obvious clock. The second mystery is even more profound: its surprisingly fast spin. When a star expands into a red supergiant, it should slow down dramatically. Think of an ice skater extending their arms to slow a spin. Based on its enormous size, Betelgeuse's rotation should have slowed to a crawl. Instead, observations suggest Betelgeuse is spinning at a brisk 5 kilometers per second. That's much faster than simple single-star models predict. For years, competing ideas tried to explain this. One hypothesis suggests the rotation is just an illusion, and that massive, boiling bubbles of plasma on the surface are mimicking the signs of rotation. But another, more tantalizing theory was one of cosmic cannibalism. The best way to spin up an old giant star like this is for it to swallow a companion. The theory proposed that sometime in its past, Betelgeuse devoured a smaller star, and as that star was absorbed, it transferred its orbital energy and spun the supergiant up like a top. It was a compelling story, but it was hard to prove. Until now, the evidence has been pointing in a very interesting direction. The key that would unlock Betelgeuse's secrets appears to be hiding in that strange 6-year rhythm. For decades, the idea of a hidden companion star was a leading but unproven theory to explain it. The problem was seeing it. Trying to spot a small, dim star right next to a celestial searchlight like Betelgeuse is an incredible challenge. But in the last few years, using advanced techniques with the Hubble Space Telescope and powerful ground-based observatories, scientists finally found the proof they needed. They didn't see the star directly at first. Instead, they saw its wake. In a landmark study, astronomers announced they had detected clear evidence of a companion star plowing through the outer atmosphere of Betelgeuse. It's like a boat moving through water. As the smaller star orbits, it appears to carve a trail of gas, a wake, through Betelgeuse's thin, extended atmosphere. By tracking the data, the team found that every 6 years, as the companion star passes in front of Betelgeuse from our viewpoint, this trail measurably changes the light we receive, causing the long-observed dimming cycle. The timing was a perfect match. This was the smoking gun. The 6-year cycle wasn't coming from inside Betelgeuse, it was almost certainly being caused by an orbiting partner. This companion has been given the suggested name Sawarha, reportedly from an Arabic word for her bracelet, a poetic nod to its orbit around Betelgeuse, whose own name is derived from the hand of the giant. Some have even nicknamed it Beetle Buddy. So what is Sawarha? Based on models, it's thought to be a smaller star, perhaps around 1.5 times the mass of our Sun. It orbits Betelgeuse at a distance of several astronomical units, And most importantly, this orbit is within the tenuous outer atmosphere of Betelgeuse itself. Sawara seems to be a star swimming inside the atmosphere of another star. This isn't just a binary system, it's one of the most intimate and bizarre stellar relationships ever confirmed. The confirmation of Sawara's influence is a huge moment because it doesn't just solve the mystery of the 6-year cycle, it provides a framework that helps make sense of Betelgeuse's other strange behaviors. Let's go back to that fast rotation. The theory was that Betelgeuse had swallowed a star. Suddenly, this doesn't seem so speculative. The discovery of Sawara proves that Betelgeuse does form systems with other stars. The existence of a current companion lends powerful support to the hypothesis that its rapid spin is the ghost of a former companion. Betelgeuse may indeed be a cannibal, and its spin is the lingering evidence of a past meal. What about the Great Dimming of 2019? While Sawara did not directly cause that specific dust cloud, its presence likely plays a crucial role. Think of Sawara's gravity constantly stirring the pot. As it plows through Betelgeuse's atmosphere, its gravitational pull would likely agitate and disrupt the supergiant's already turbulent surface. While still an active area of research, this constant disturbance could make Betelgeuse far more unstable and prone to the very kind of massive outbursts that led to the Great Dimming. This single discovery reframes our entire view of the star. Betelgeuse is not a solitary giant raging against the dying of the light. It appears to be one half of a dramatic, interacting duo. Its flickering, its outbursts, its spin, they may all be symptoms of this cosmic dance. And that dance is heading towards a spectacular finale. The same atmospheric drag that allows us to see Sawara's wake is also likely sealing its fate. The constant friction is probably causing Sawara's orbit to slowly decay. Some models predict it is spiraling inward, and long before the supernova, another merger event could take place where Betelgeuse devours it. So, we have a compelling new answer. A big reason Betelgeuse behaves so strangely is likely because it has a secret companion, Sawara, orbiting within its own atmosphere, churning its surface and leaving a wake that marks time like a cosmic clock. This discovery strongly explains the long-standing mystery of its 6-year cycle, provides a plausible reason for its rapid rotation, and helps us understand its violent instability. The story of Betelgeuse has transformed. It's no longer just the story of a single star on the brink of a supernova. It's the story of a complex, possibly cannibalistic system, a celestial drama playing out over millions of years, with one star perhaps already consumed and another on the menu. The science, of course, continues. Astronomers are eagerly looking forward to future points in the companion's orbit, like in 2027, which may offer a key opportunity to image it more clearly and refine our understanding. What other secrets is this system hiding? What do you think is the most incredible part of this discovery? The star within a star orbit? The cannibalism theory? Or the fact that this was all happening right under our noses? Let me know your thoughts in the comments below. And as always, thanks for watching. Keep looking up.